Hello students, welcome to Lab D4, and this is Series RC circuits. Now remember, when we introduce resistors and capacitors in the same circuit, we have reactive components, and there's going to be a phase shift. So we'll have to look at phase angle here in just a little bit. We're going to build a circuit in the schematic there. This laboratory begins on page 86. So page 86 is where you would find this, and this is where it begins. And we have two resistors and two capacitors in series, and this is what it looks like on a proto board or on your trainer. Here is my capacitor 1, or resistor 1's down here, capacitor 1, resistor 2, capacitor 2, and they're hooked up to my 6 volt 60 hertz source behind there. So simple setup as far as building that circuit. So there's going to be quite a bit of analysis here that you'll need to do on this laboratory, so let's take a look and see what that looks like. We are going to look, and it should tell you on the page there what we're doing. You can see on that introductory page on page 86 is you're going to do similar to what you've done in a couple of previous labs as far as measuring the capacitors, the capacitor resistance. You're going to calculate the inductive reactance, or capacitor reactance, sorry, the capacitor reactance, then measure resistors. And once you've taken a look at your components, you're going to build this circuit. And what you want to do in this circuit is you want to make sure that your source is set for 6 volts at 60 hertz. And then we are going to measure the voltage on R1, the voltage on C1, the voltage on R2, the voltage on C2. And we're going to measure total current. And then we're going to calculate our total impedance. And we're just using Ohm's law for that. And then we're going to calculate our power using Watt's law. And then we're going to find theta and the power factor, and then also record the polar rectangular forms. So those are the different activities you'll be conducting in this laboratory. So let's assume that we have done our measurements and we've calculated our power. Then what I would do when I'm doing my differentiating the volt amp reactance from the power that's dissipated on these resistors in the form of heat is that if I look here, is that if I add up my 2 VARs for my 2 capacitors, that's going to be the blue line over here. That's a minus 2.19 millivars. And if I add up my power that is on my 2 resistors, that's going to be the horizontal line, that's the red line there. And then I can calculate what the power is by using the Pythagorean theorem, where the total power is the square root of VAR squared plus millivolts or milliwatts squared. So that's what I have here as far as these numbers are concerned, and I get a total of 3.76 millivolt amps. So you'll need to take a look at these numbers. Your numbers may be a little different. I'm just using this for an example's sake. So we take a look at that, and then we're going to figure out some of the other stuff that we need to figure out. One thing is that if I'm trying to, this is another way that we can look at how to figure out theta, and I just sort of redrew this from the numbers we had on our power triangle there, and that's one way to take a look at that. If we're doing the polar, the angular displacement here from my 0 line, is I come up with the inverse tangent of the y over x axes, and when I do that, I get something close to about 35 degrees. I also want to calculate the power factor, and these are the numbers for power factor. It's just the cosine of watts over volt amps, and you're going to take a look at that and do the calculation for that. And then once I take the x and y numbers I have here, I can simply write that in a rectangular form, where 3.06 is my x-axis, and the J factor -2.19 is going to be your y-axis, and it's negative because it's it's going into the negative area of your Cartesian coordinate. So hopefully that will help explain some of the information you're trying to find. Also, there's some questions that you'll need to answer, so make sure you check with your lab instructor to make sure you've completed the lab properly and you can check your answers. And then also all the cognitive questions along with this lab, you want to make sure that you take a look at and make sure that your answers match what the answer key has. So look forward to seeing you in lab. I'll see you then.